Hi, my name is Professor Matt Probert. I'm at the Department of Physics at the University of York, and I'm a theoretical condensed matter physicist. I'm involved in various parts of the undergraduate teaching and the postgraduate teaching. My speciality is things to do with computational physics and theoretical physics. So at the moment I teach courses in second year. I run the theoretical physics version of laboratory, which is called computational laboratory. I teach part of the Maths 3 module, which is a second year course. And then in later years I teach some more advanced things with computational and mathematical interests, culminating in year 4 with high performance computing, where we teach our students how to use computers efficiently as a tool for doing their science. So we're teaching the nuts and bolts of how to write parallel programs, how to use supercomputers, because that's what I do for my research. So for my research, I develop computer programs for using quantum mechanics to study and explain the properties of materials. So I've got various exhibits of different materials that I've worked on over the years. So this material is called silicon carbide. It's a man-made material made by mixing together silicon and carbon, which have the same crystal structure, and it makes a material that's almost as tough as diamond, but it's almost as cheap as sand. So it's a fantastic material to use in technology, and so we try and understand how we can make new materials like this. So we model them in the computer, and then we can work out their properties and then make something that's useful for everybody else to make use of. So the undergraduate teaching I do, it kind of leads up to that kind of application. Do some graduate courses on how you can do materials modeling, and then as research for postgraduate work and above, that's what we do. We develop computer programs and algorithms, and we apply those algorithms and those programs to study matter at the level of atoms and electrons and how that all fits together. So I've got quite a lot of research students working for me at the moment, and we make a lot of use of different facilities, from desktop computers up to the biggest supercomputers in the country. And we use that because the equations we're trying to solve, although we can write them down on pen and paper, when you try and solve them, they turn out to be impossible to solve using pen and paper, so we have to solve them using computers. And the more complex the material, the more electrons it's got, the more work it is to solve those equations. So we can keep a national supercomputer busy for hours or days at a time to solve the equations for just a single material. It's kind of mind-blowing when you look into the size of the numbers and how big these computers are and what they can do.